Welcome to Hypers Mods, home of the Blueprint Node Nuggets, your quick bite guide to mastering Unreal Engine Blueprint nodes. I'm Hyper, and today we're unlocking one of the most fundamental but powerful nodes in Blueprint Arsenal, the branch. A branch is an if statement. It evaluates a boolean, it's either true or false. There's one input, two outputs. I've set up some ways to showcase how they're used, and I'm going to explain common scenarios that you would find them in. These are very common. If you're a game developer, you'll probably run into situations you use this all the time. And again, this is what it looks like. If you want a hotkey for how to get it, you just hold B and click. That's a left click, and it will appear wherever you click. Super easy. And to make a variable, we already have one here, but I'll make another one just to show you. We'll make a boolean. So you click the plus here to make a variable, and then we'll go and set that as a boolean. And if you hit F2 or double click on the name, you can change the name to whatever you like. And we can drag that out and put it there, or we can hold Control for a get, hold Alt and drag out for a set. And if you're not a fan of hotkeys, you can just drag it out and click whichever one you like. I've made a couple of things. The first one is this. We can kind of ignore this for the moment. I'll disconnect it so it's not in the way. Kind of put them down here out of the way. This is very similar to what I was just showcasing. This is begin play. If you want to get this on the event graph, I can't get it again, but you would hold P and left click, and it would appear wherever you click, similar to the branch. I turned it into a function just to save memory. If it's on the things on the event graph, stay there for as long as the actor exists. So it's always a good idea to turn these into a function if you can. If you have a latent action, so if you have things like a delay or a timeline, those have to be on the event graph. So whatever's connected to them, that has to go through the event graph at some point. But I'm not using any of those today, so we turned them all into functions just to make it a little bit easier on the memory. This again is a static bool. It's not changed ever. So right now it's set to false, and I have it set to print some, basically a metaphorical door. It prints open if it's true, false if it's closed. And so right now it'll be closed. Again, it's a static bool. It's not changed by anything at the moment. So if I start our thing here, we kind of ignore some of those other prints I have, but the top one there says close, and it was false, so there's no way to change that currently. And if we change it to true, it'll say open. Very simple. So if we had a door or something, we could have some animations and so on to do that. But this is just explaining Blueprint nodes exclusively. I do have some more advanced things on the next part here. I do need to enable input. And all this does is it allows me to put in key commands, which I put down here. These have to be on the event graph as well. So if we hit numpad 0, it will set our integer to 0. Numpad 1 sets it to 1, 2, 3, 4, and 5. Very simple. It's just to showcase some ways that you might use a branch in your game development. So this is on tick. Again, I turned it into a function. The way you would do that is just right click it and convert to function. This one is saying for me to convert it back to an event because I had already converted it from an event. Right now we have on tick a bunch of booleans set up in different ways. The first one says if it's equal to 0, we're going to print that it's equal to 0. And if it's not equal to 0, we're going to see if it's equal to 1 or 2. We have that connected to a branch. It'll print that it equals 1 or 2, and so on. Here's 3, and there's 4. If it's not equal to any of those, so we know it's not equal to 0 if it passes this way. We know it's not equal to 1 or 2 if it continues down false. We know it's not equal to 3 if it continues down. And it's not printing any of these because they were all false. It would only print one of these if it's true. And if it's not equal to 4, we know that it's either more than 4 or less than 0. So we know that it's not any of these because none of these were true. Because it's all the same value. It's all the same variable. It can't be equal to more than one thing because it's only one. And an integer is just a whole number. It can be negative or positive, but there's no decimals. And again, my key presses that I have set up over here on my event graph, these just change the numbers, the values of that integer that we're reading on tick. And another thing that's good to know is having it set up like this, where you're reading the values multiple times. This isn't really resource extensive. This is very, very simple. It doesn't even have to think about this really. But if we have more complex games, say that you have a bunch of creatures, bunch of actors, they have health, they have stats, they have experience, whatever your game entails. And we're checking their experience. Do they have enough experience? Do they have enough levels? Have they killed the right amount of things? Done enough damage? Have they done X, Y, or Z? We kind of want to do an individual branch for each one of those checks. So we'll do, say, this is your experience. Has it done enough damage? Has it played the game long enough? And we'll connect these to each of the branches, and true, true, and then we'll do the thing at the end. The alternative to that is saying has enough experience, has killed the thing, has the right companions, has a pet dog, and then we connect this to one branch. In Blueprint, to continue the metaphor, I'll just connect these. This would be this would be your character, and like you'd get the character stats, you'd get its companions, whatever you're looking for. In Blueprint, it runs, these are all pure, so it runs all of these at the same time. And say that this one failed, it would be better to just do this, because this one fails, it's not going to continue to this one. So if you do all of them at the same time with this OR, which this would actually be an AND in this case, but I got OR, it's running all these at the same time. So it's getting all of that information, which in some cases can be resource intensive. And if one of them fails, then you just wasted your resources on the other 3 or 4 or 5 or 10, depending on what you're doing. It would be better just to make a bunch of branches and say do step 1 and then do step 2, and then if any of those fails, you don't waste resources continuing, because you stop there, you're done. That's where it differs from C++, because in C++ it does that on its own. You can just say these values equal to whatever, and it'll stop whenever one of them fails, instead of doing this and then getting all the values and then passing it to the branch and saying one of them failed, but we got all the information anyway. And then the only alternative to that is if you needed the information anyway. So if you had, say, a sequence, you use the value down somewhere else, even though it failed. So it's just kind of situational. But I'll showcase this here. So now it says equals 0, because that's the default value. If I press 1 on my keypad, it says it's equal 1 or 2. And then 2, still equal 1 or 2. And then 3, 4, and if I hit 5, it's equal to either more than 4 or less than 0, because it's none of the other values. And I can just kind of go through those pretty easy. On the bottom right, you can see what keys I'm pressing. And then if you want to see that running, I'll put my thing on the other screen here. So currently it equals 5, so it's printing this. And if I press 2, you can see it goes to 2. It goes through the true. And then if I press 1, it does the same. 0. Now it's not equal to the other ones, it's just going to flag for the first one. And then 3, 4, and 5. You can kind of see what the branches are doing. So say, like I was explaining earlier, it's not equal to 0, so it's not going through true. And then it's not equal to 1 or 2, so it's just continuing down false. It is equal to 3 currently, so it's going there and it's printing, but it's not doing any of this. So this is, if I had an AND on all this would be a wasted value, because it flagged here. And then in the same thing, if it was on AND, I would have gotten all this information and it failed the first one, so there was no reason to continue. Where in this case, if you have a continuance of it, it does true, false, true, false, true, false until it continues, till you tell it to stop. And it's just a lot of if statements. So if, continue on. And then for the a little bit more advanced situation, show you what you can do with branches. This is a little bit more on the AI track and keeping track of where the player's looking and stuff like that. We have a more advanced blueprint here. So this gets the only player controller, the first in the list. I am only using one player, so it's going to be the only player on the map. If you have multiple players, you'll want to get all of them and filter for the one you're trying to get, or maybe get the closest. So there's a couple of options for this, but for this use case, just showing you what branches do, I'm just getting the only one on the map, which is mine. Multiplayer games, you can't really do this. Single player games that doesn't have co-op and stuff, you probably could do this, it'd be okay. So the first one, we use a branch here for is valid. We want to make sure that there is a player on the map, because if there's not, we don't need to do anything, we're done. And so the player controller, or you as the player, if it's valid, we set that to a value, a local variable. And local variables are dumped as soon as the function ends. So it's not stored in memory, it doesn't stay relevant forever, it's only relevant to this function when it's fired at that time. And then we get the controlled pawn, which is the actual player actor. And if that's valid, then we set that to a value as well. If it's not valid, we're done again, because we don't need to show anything, because we can't do anything. And this is a sequence, so it says then 0, or go this way. We're drawing a sphere trace, which is like projecting a circle forward until you tell it to stop. And if there's anything inside that circle, it will come out here and tell us what it was. And I'm getting the controlled pawn, which is the player mesh, and I'm getting its location, and I'm offsetting it by 70. So I'm going up toward the sky about 70 units, and that gets about the head location. And I'm adding that to the forward vector multiplied by 3000. And the forward vector means that it's the direction the player's looking, and I'm multiplying that by 3000. So I'm saying go forward 3000 units, which is a pretty good distance. As far as this is concerned, that's just an arbitrary number that was far enough to just find something. But I'm saying go forward that amount and add that to my location. So at my location, go forward the direction I'm looking about 3000 units. And we grab the actor location, so the player's location modified by 70 upward for the head. And I'm saying start there and then end at my location 3000 units in the direction I'm looking. And the sphere size is about 10. That's like a watermelon size as far as the scale for Unreal. Kind of small. And then I'm checking for world dynamic and world static. These are the things I'm trying to hit. And I'm saying ignore my pawn. So I don't want to hit myself. So if I'm drawing a circle forward, I don't want to run into my own character because I'm not looking for that. And by default, it ignores self. And I'm doing this on an actor that I made just to showcase branches. It's just a sphere. And I don't want to ignore self because I'm actually looking for self, its own actor. And then another 2 branches here. If I hit something, true, then we'll keep going. If it's false, then I'm just going to say we're not looking directly at the actor because we didn't hit anything, so we're not worried about checking to see what it was because it was nothing. And then continuing on that, we can pull off our hit and say break hit result, and that's what this is. It's just a struct of information based on what was hit by the trace. And for this, I will turn on the debug trace so we can see what we're doing. And the actor that we hit, if it's equal to ourself, then I'm going to print looking directly at me, which means that our character is looking directly at this actor. And that would be useful for, say, guards, or if you've ever played like Lethal Company, there's like a spring head, I believe, in that game, and you have to look at it for it to not move. And this is a prime example of how you might do that. You have to look directly at this orb in my instance, but there's another instance that I'll show you here in a moment where If it's just kind of in a certain angle, like a cone going forward, it will also print something else. But we're not there yet. We'll do that in a second. So basically, again, we trace forward, and if we hit this actor, it says you're looking directly at me. If not, you're not looking directly at me. And then we'll go ahead and test that, and I'll bring the screen back over here. And now you can see that it's projecting that sphere forward, and you can see when it hits the wall that it turns green. That means that we hit something, and that was the object that it's outputting, which it is not the actor that I made. As you can see on the right of my screen, that is the actor that I made and that we are trying to detect for. And so it's not printing anything. It says we're not looking at it. And then if I get a little bit closer, and now you can see it's colliding with the sphere, and it says you're looking directly at me. And that's kind of how that works. And if I'm not looking at it, even if I'm like close but not quite, it looks like the collision is I'm hitting the edge of it there. And see, that's kind of the benefit of using a sphere instead of just a line trace, because it's not like a pinpoint. You have a little bit of forgiveness on that. But yeah, that's pretty much it. And you can see that it follows the head. And there we go. Pretty simple, but that's a good semi-advanced way to use branches. You'll see them in scenarios like this all the time. This is very common. Validation is what we would call this. So you're validating your information as you go, because you don't want to waste resources. You don't want to, if I take all these branches out, I'm going to do this every single time for every single thing. And I'm just going to waste a lot of resources, because if my controller is not available, why am I going to keep looking? There's nothing to show. And then same thing for the pawn. Like if it's not valid, I'm not going to keep going. There's no reason to. And for the trace, if I hit nothing, then I don't need to try and print anything because I didn't hit anything. And then if it's not the same actor, again, you're just validating everything. Branches are great for validating everything. And then I'll reconnect this. This is an alternative to a branch. This doesn't actually use a branch, but it's the same idea. So it's basically, they're called select nodes. And this is a wildcard select, meaning that you can change it to whatever you want. You can use booleans, you can use integers. You can use any type of value. For this case, we're using booleans because we're replacing a branch. And instead of saying an executable true or false, we're saying pick A or B. Very much the same usage. But these will allow you, they look a little bit prettier sometimes. And if you're going to print either way, so up here, I print whether I'm looking at it or not. I tell you, you are or you are not looking at it. And if I'm doing that, then that's the case you would want to use these, because you select string, which is just a sentence basically, or words or characters, and you say true or A, I'm doing the thing, or B, I'm not doing the thing. Very much same thing. And then select for color, can change the color of the print as well. Same idea, very common. And some people just don't like using a bunch of branches, especially if they're doing the same thing regardless of which side the branch is, and they're just changing a value. This is an alternative to a branch. And what this is doing is it's getting our pawn, and it's saying get the actor transform, which is the location, rotation, and scale. In this case, we only need the location or rotation. That's also pretty common. It's not super often you'll use the scale for many things. And we're finding the look at rotation, meaning if I'm standing at the start point and I'm looking at the target point, which is a vector, it's just a point in 3D space, what is the rotation that I would need to be at to find that? I actually made this function for nearly equal rotator. The Unreal Engine does not have it by default. I'll show that in just a second. But if those rotators are nearly equal by error tolerance of 30 degrees, it'll say true. If they are not close enough, it will say false. Here is the function. It's just nearly equal for float, and you connect your rolls or your X values and then error tolerance. You connect your Y values and your error tolerance, and then your Z values and the error tolerance into an and then we'll go ahead and showcase that. So if I'm looking within 30 degrees of my sphere over there, it will pop up and tell me I'm within 30 degrees. So I'm looking directly at it and I'm within 30 degrees. And to the side, I'm looking within 30 degrees, but I'm not looking directly at it. And same thing for this side. And that's probably like 32 to 35 degrees, and 30 to, you know, you can kind of get the idea. This is more of your spring head idea from like Lethal Company. And that's just how you would have players making sure they're looking toward or nearly toward something, and then even directly at it if you wanted to, but a bit more specific. Thank you for watching, like and subscribe, and have a fantastic day.